The last one I'll talk about, I'll try to do this pretty quick, is peering. And peering is something like pretty much everybody has to do. Usually whether it's enterprise or SP. This is probably slanted a bit more towards SP peering. This is something that Kevin talked about earlier in the day, is how we see kind of traffic distribution happening. And really kind of the traditional content versus optimized. It's that notion of like flattening of the internet, which is not new. It's probably a 12-year-old term at this point. And it's really, and I think like Jeff Houston had a good paper, like the death of transit. You talk about that because a lot of the interconnection and the content delivery is between provider and content provider today, or service provider and eyeball and a content provider, and not so much through a transit carrier. In the US, I think upwards of like 85% of the traffic today is not over transit anymore for a number of different reasons. So kind of the eye chart on the right, the graph there is really kind of the evolution of like where you see traffic being delivered from. And years ago, or even 2010, it was over like a long haul core, and that's where, this is a very US specific example, but US has 6 or so really big peering locations, and people just built their long haul networks to those locations. Today, we're seeing people build more peering locations, whether it's local IXPs or third-party facilities. There's a lot of companies that have sprouted up to build these kind of metro kind of peering facilities over time. And now there's some that are looking to build them even like, with 5G coming, like at the tower or at a cluster of towers. So, one company that we're working with today wants to build, 1,000 of these centers in the US. And they want to put Netflix there and all those different providers there for content delivery. But it's just many more different, peering locations across the US. I would say the US is a big geographic area. We don't see this so much in other areas like Europe. So Europe is much smaller geographically. They still use traditional, IXs pretty heavily. Like Amsterdam is a huge IX. And that gets into like public fabrics versus private interconnect and things like that. Like I said, the US public fabrics have kind of died off. A lot of the traffic's private interconnect today. Do you have a question or no?
No, I was just thinking about the model because I do a lot in Europe. I was thinking about DKIC. DKIC has actually recently moved to the US and has a big presence in the US now. They moved to Dallas. They've always been in New York, but they recently opened up in Dallas.
Yeah, and when you talk,
doing a lot of reach out into the United States for
exactly. Yeah, there's other, that's a different peering topic, but yeah, the IXs and IX just doesn't mean one location anymore. AMS IX is everywhere.
That's the interesting thing is the IXs are not as geographically like it used to be. Like you said, AMS IX was in Amsterdam. Now it's everywhere.
Exactly. Yeah, they support more services. So like how do we support these deployments? We have things we call like a peering fabric, and it's a notion of like. We have two different kind of designs of this. We call it kind of an integrated peering fabric. That's, and really we decompose the functions of peering into kind of two different functions. One's core connectivity and one is peer termination. And the peer termination function really encapsulates things like security as well and telemetry associated with like NetFlow and things like that. Is that component? So we kind of have two different flavors of topologies and I'll go to the next slide of like which one may work. And the first one looks very much like a traditional peering deployment. It's probably a bit more scale out design than like the 2-box or 1-box that's sitting there, and that gets into the kind of the pizza box thing. And part of that is because like and as we kind of push peering sites deeper in the network, there isn't space and power is pretty important, and being able to build things granularly it becomes more important versus deploying just the 2 big boxes. Although some people just deploy 2 big boxes, and that's fine as well. So here's kind of like the different options. Traditional was just kind of 2 devices that are sitting there. So really, kind of what we espouse is more of that scaled out approach to it. It comes down to the same tenets of blast radius, building things in a more granular way, in building blocks, and really kind of when we look at like the distributed fabric, that is really more of a leaf spine CLO type fabric. And when we look at that, the place where that makes a lot more sense is a place where you have a lot of both ingress and egress delivery, really more east-west traffic. So if I have a leaf with a content source, sending egress traffic, we're actually seeing more of that because traditional kind of eyeball providers are starting to provide services external to their networks as well. So like things like TV services. There's one example, I won't mention it, but But as things consolidate from a media perspective in the US especially, we see ingress providers become egress providers. So things like that become a little more important. Really, where does that fit in the network? Anywhere you do peering today, whether it's a local peering facility, a traditional IXP, or this peering fabric extension is really like, if I'm at an Equinix, because Equinix today is, Equinix and Ashburn might, it's not one building. Not everything's in one building. There's stuff everywhere.
There's a couple in Ashburn.
Yeah, a couple. Or
Just a couple.
Or
Just
Chicago.
A couple DCs there.
Exactly. So even Equinix is a bunch of buildings. So it's like how you connect into that, how you interconnect things. So it may be easier to put a small box there and extend that fabric than to pay for fiber cross connects from facility to facility. It depends on like Coco. There's a lot of aspects to that, but having a small box that fits within a small power footprint may be an easier option long term. And then edge data center peering, it kind of gets to the 5G story. You guys hear a lot. There's a lot of talk about MEC or mobile edge compute, and it's less about peering in that case. It's more about caching. It's more about where I put caches in the network, how I connect those caches to my network. And like I said, some of that kind of remains to be seen as that infrastructure is built. But you've got to have to be ready to support how I connect those devices at that part of the network. The control plane is pretty simple. That was kind of the goals. It looks like traditional peering. That's pretty much what it is. You do BGP. You run ISIS or OSPF within the peering domain. And so within these different designs, we do give prescriptive configurations on how to configure these things. With peering in particular, it's I'll say Metro Fabric is the IGP is very ISIS based as far as the examples go. It's just what we focused on to begin with. Doesn't mean you can't do OSPF because we do support OSPF for SR. But we did look at supporting like RSPTE and OSPF as part of peering because peering is usually tacked on to another part of the network. I'm not going to change the rest of my core based off peering. So we try to interact or validate, and like I said, a big part of that's the validation part. So we validate those protocols as part of the integration testing. A simple content provider example, and that's really where we see the more of the like leaf spine being a better option because I do have sort of any-to-any traffic between my sources and the different peers. So another topic that we get asked about a lot is around traffic optimization from peering to either from peering to my users or from some place of my network externally. So in this case, like when we talk about ingress peering traffic optimization, we're really talking about how I get traffic from a peer to a specific user on my network. How do I optimize that path? And really SR is the way that we do that because I can have that prescriptive path end to end. We haven't talked a lot about Way. So Way is it's a Cisco application or product that we have that takes topology. It can compute bandwidth optimized paths across the network. So in this case, we have APIs that run between Way and SRPCE. And so what we do is we have SRPCE give the data to Way, and then Way uses the API on SRPCE to build that path. Another specific example is around egress peer engineering. That's how I get traffic from my network to a specific peer. And in this case, we actually use a very specific SR feature called EPE or egress peer engineering. So some time ago, there's IETF draft on this specifically. Is people thought it would be nice if I could address that peer using just a SID on the network. Whether it's a set of interfaces represented by one SID, or it's a node or an actual exit interface that's represented by a SID, it allows me on the head end to just reference that one SID and send traffic to that path. That's really what we're talking about here is being able to select a specific peer based off some sort of constraint criteria. I don't show up too well, but here's sort of like what the data plane looks like for that. So in this case, like this peer adjacency SID, that's a specific SID type in SR. So you can find the IETF kind of RFC or draft at this point on how that works and how I address that specific SID. But what happens is, and I don't show SRPC here, is like the peer adjacency SID gets advertised, through BGPLS to the PCE. So the PCE knows how to get to that SID. And really, all you're doing on that the nodes on the right is building that label stack to get to that exit point. So I have this prescriptive label stack that means that traffic will always end up at that SID. And one thing to keep in mind is the intermediate nodes, like ECMP still works across all of that. The parts of the middle are still kind of ECMP optimized unless I pick specific links or specific nodes with different SIDs. This is probably the only hardware slide you'll see today. So really, like for peering, what we're focused on today, we have a lot of deployments using, say, ASR 9K, ASR 1K, XE, XR-based devices. For service providers in general, though, NCS 5500 series is kind of what we're focused on in peering specifically. It gives us, very large scale and flexibility. It's from power and space and things like that. It's a very high scale, and I think as was mentioned earlier, all these platforms, they are commodity chipset platforms, specifically. If you want more information on that, just let me know. And I'll say, like, with that hardware, people bring up things like fib size, rib size, things like that. The fib size on most of the devices is 4 million routes today. So there's a lot of
So that'll last for a year.
Yeah, I think we're like 760,000 V4 routes I think today. But people, I don't know how much more it's going to grow, but it'll all continue to grow. V6 especially. So, but we have some headroom today. And like I mentioned, with all the designs, we have focused on like kind of telemetry. The one I think that Santiago and Mike talked a lot about was the model-driven side of things, which is kind of the new hotness and how I get data, operational data off the devices. But I always look at telemetry kind of like the capital T is the traditional telemetry, especially for peering. Things like NetFlow is important. So making sure that we support all of the proper protocols for doing NetFlow, making sure that we have good export of NetFlow on the device themselves, and then also supporting things like BMP, BGP monitoring protocol. I've got another whole slide deck on some of that. But one specific open source project we have is SNAS.io, which stands for Streaming Network Analytics Collector, and it used to be called OpenBMP. But it's a good platform for ingesting BMP information and doing all kinds of analytics on that. And you can use it as a collector and output to like Kafka, or you can use its own built-in sort of analytics tools to do things to monitor things like BGP peer stabilities, ASN changes, things that are happening that you want it to monitor that are BGP related. Another thing we try to do is build automation for peering and make peering look like any other type of service. So really the idea around this is using NSO to abstract what you're doing. So you may have like sort of a canned profile for specific peers. This makes it easier to manage that, as well as do things like add interfaces. So if I'm expanding a bundle to 3 versus 2, I just have simple automation to do that goes out and configures the devices to do that. And the big thing that I always say is what NSO allows you to do is configure things much faster. It also allows you to delete everything holistically as a service. So if you look on most routers, like peering routers today are even at web carriers, or web providers, they're managed pretty individually versus like a data center device. And there's a lot of cruft on there that's left because people don't delete things. NSO takes care of deleting things as well as configuring things. And that's kind of one of the main benefits. Obviously security. And like I said, I've got a lot more information on this online if you want to look. But looking at peering security, peering is the edge of the network. Obviously, it's where there's a security boundary between you and the rest of the internet. And this kind of looks at some of the kind of SP concerns. And I guess I'll need to update this for 2018. But like DDoS attack is definitely a big one. And I'll say like within the fabric itself, we're not doing DDoS protection, but we're making sure that we support all the things like FlowSpec, NetFlow, in ways that can enable someone to do better DDoS protection at the edge of the network. Like I said, through pretty scalable NetFlow. One-to-one NetFlow is not going to happen at this point. It's on an SP box. But getting to 1 to 1,000 is pretty good these days. And Dan talked a lot about trustworthy systems and how we're looking at peering is typically a lot of times deployed in third-party data centers, making sure that we have the hardware part of that trusted. There's things we're doing with like BGP route hijacking. There's a product that's eminent Crosswork network insight. It came from a product that was sort of an open source community thing years and years ago. BGP Mon. So BGP Mon, there's another BGP Mon now, but this is really the one that does kind of route leak detection and route hijack detection. It became a Cisco product some years ago when we purchased OpenDNS. But we've kind of revamped that and modernized that product into something that's a bit more modern and usable today. Another thing that's seen a lot of recent noise is like RPKI and ROV. That's something we've supported for many years now, even though it hasn't really been utilized very heavily. But we're definitely seeing Cloudflare enabled it, NTT US enabled it for like invalidated I would say like for bad prefixes, for actually dropping bad prefixes instead of just kind of monitoring. There's still some hurdles with RPKI, but we're making sure that we support that as much as we can. So I said DDoS mitigation is really about detection. And then about how I get traffic either to scrubbers or how I block traffic. And like I said, we're making sure that we support all the kind of proper interfaces and things to do that. One thing we focused on is doing pretty high scale ACLs at the edge for blocking some of those things, both with and without flow spec. And then really looking at SR and using some of the features of SR to be able to better redirect and send traffic to like a scrubbing device and load balance specifically. Another thing that's like always a good topic is, I think the colors didn't come out too well on here, is things about doing like peering in internet tables at a VRF. It's something we've seen, it's become more popular over time as the capability of boxes has become better. So we've validated this as part of our design. We're not at this point saying this is absolutely what you should do. But we've validated that the operation within the hardware that we specify in the design and all the control plane works fine. And really, this is an infrastructure security. If I can isolate the internet from my infrastructure layer, that's a benefit to doing that. The other thing is like peer-to-peer isolation. We don't really see it. Like I said, public fabrics are not as popular, so there's not so much like peer A is trying to use me as a transit. But this basically solves that issue because he has no routes to that other peer. He only has routes to my network and not the global routing table. There's other ways to solve that issue, but it's kind of one of the side benefits of using either peering or internet, global routing table in a VRF. This is the last slide. Like I said, this is just kind of a screenshot from Network Insights, and it's really meant as a tool to monitor route leaks and monitor route hijacks. And it does that through kind of a worldwide network of connections to either things like route views, like IX views. It basically ingests lots of routing data and lots of routing change data, and uses a lot of heuristics and machine learning that I don't understand to then say, hey, this is to try to cut down on some of the false positives. If you listen to all the sources on the global internet, you see a lot of false positives, and because there's a lot of churn in the internet. Period. I think these days BGP routing updates, there's thousands per second in the global routing table. So being able to identify what's really a route leak versus or an ASN hijacking versus some kind of other transient event is sort of the secret sauce that this does. Maybe it could have caught the unfortunately, it can't mitigate the route leak. It could tell you it happened, kind of like what happened this morning. But at least if, like, say, your prefix is being affected by either a route leak or a hijack event. The last few slides are just additional resources. So the validation labs that we have for each one of these designs, we put the configs online. They're all on GitHub. There's a link off of the xrdocs.io page on how to get those different configs that are part of the validation. And just other information on things like EVPN and segment routing, which are such a big part. those are kind of our, no, you guys can't get to those. But anyways, we have we have public ones that you guys can get to. Actually, yeah. So basically, segment-routing.net we have, and EVPN I think .io are public sites that have much of the same kind of they go like for instance FlexAlgo. So FlexAlgo, we have great presentations on segment-routing.net on the operation of that, videos on the operation and things like that. And things like core and peering, it's kind of the same thing. We've got a bunch of different resources on finding more information about that. So if anybody's interested in sort of the NSO automation part of it, just let me know, and I can get a hold of that.